In the last part, we had just determined that 50 hours of work would result in a pay of $412.50. A lot of times also, you probably are used to this, we would put our units up there as well just so we know what these are representing. So 50 hours corresponds with an output of $412.50. So is this a function? Well, can we say that for every number of hours that there will only be one pay? So if I work 60 hours, can I figure out my exact pay? The answer is, of course, yes. That unless you're getting paid two different rates, that doesn't really make sense, right? To get paid $412.50 and get paid $500. If you work 50 hours, you get one pay associated with it. So we wrote it this way. Now, how would we write this in function notation? We would say that the pay is a function of the number of hours that you work. We know now that if we wanted to find or evaluate, remember we're using evaluate to state, given an input, what is the output? If we wanted to evaluate this statement, pay is a function of 50 hours, our answer would be the pay is $412.50, and that is a function of working 50 hours. Because P and F of H in the last section, or last portion, we mentioned that since these two things are equivalent to one another, I can replace P with this any place I see it. That's the basic idea of equality. If things are equal, that means they're interchangeable. So I can also write this equation as F of H equals 8.25H. And you'll notice I'm saying F of H. I don't say F times H because this is not multiplication. I'm not saying that F multiplied by H is equal to 8.25H. I'm saying a function of hours is calculated by $8.25 times the number of hours worked. Well, what do I mean by function of H? Well, the function of H is synonymous to saying the pay. The pay is equal to $8.25 times H. So really there are two ways to calculate this. A lot of times we write it as F of H because we can say that F of 50, a function of working 50 hours, results in a pay of 8.25 times 50. I won't use parentheses here yet. I can use parentheses, but I'm going to just do the multiplication sign to make it so that it's less confusing at first. That a function of working 50 hours results in this pay. So I can say that F of 50 is equal to 412.5, which is the same thing I'm saying over here. It's just stated backwards. F of 50 equals versus 420.50 equals F of 50. So there are two identical ways to state things. That's really all function notation is. Let's look at another example, and we'll build another model. I'm going to back up here for a second. So in this case, suppose your DirecTV bill is typically $59.95 each month. However, you pay $4.95 for each on-demand movie you order. You usually do not view more than 4 on-demand movies each month. So what do you think the inputs and outputs are? Well, our goal is probably to talk about your bill measured in dollars. That's how we measure that. And the input is probably, well, what does your bill depend on? Well, you know it doesn't really depend on the $59.95 because, well, it does, but that doesn't change. That's the same each month. The thing that affects whether your bill goes up from there or stays at $59.95 is how many on-demand movies you watch. So I'll call this OD movies. And that's just the number of them that I watch. That's the measurement for the number of on-demand movies. So I'll call this M for movies, and I'll call this B for bill. And I'm just going to look at a couple examples right below just to see how the two are related. So what happens if I watch 0 on-demand movies? If I don't watch any, I'm not charged the per movie pay. I only pay the $59.95. If I watch 1 on-demand movie, well, I still pay the $59.95, but now I have to add to that $4.95, which puts me at, well, let's see, that's that would almost be $65